Hello and welcome to our presentation of the Virtual Reality for Cognitive Products and Production Systems project. The main goal of this project is improving the development, production and operation in the automotive industry by early integration of virtual reality. This project is industry focused and supported by the Austrian Research Promotion Agency. There are 3 partners, 1 industrial partner and 2 research institutes. First, we have the EVA List GmbH, which is the world's largest independent company for the development, simulation and testing of powertrain systems, their integration into the vehicle, as well as new fields like advanced driving support systems or autonomous driving and data intelligence. The Fraunhofer Austria Research GmbH is an Austrian subsidiary of the German Fraunhofer Gesellschaft, and in this project we're working with the business unit for visual computing. And finally, we have the Institute of Computer Graphics and Knowledge Visualization of Graz University of Technology. Through early integration of VR into assembly design and training, we can improve the workflow and provide early feedback. For this, we have created an assembly design and simulation framework in the Unreal Engine that allows users to quickly create and test an assembly. Since we can measure everything in VR, we've also created a movement analysis system that visualizes user movement as trajectories. This way, the movement of multiple sessions can be compared and analyzed to better understand training effects or to optimize the assembly design. Furthermore, we are in the process of adding collaborative aspects to both systems, providing better communication and collaboration possibilities. Here is a short example of a collaborative assembly based on a simplified battery to be assembled. Both users can confer with each other and discuss the assembly. As you can see, the collaborative space allows for spatial reference when discussing and is able to highlight the important parts for next steps. We have also integrated Immersive Analytics for analyzing sensor data from durability tests of motors, for example, which run over many cycles of similar expected behavior. The goal was the detection of anomalies in such sensor data. We've used stereoscopic views to stack sensor data, like shown in the images, and provide additional fitting tools for interaction and analysis. Here you can see an overview of the components, and of special note is the proxy in the middle, which acts as the main interaction with the visualization of the data. By manipulating the proxy, the data visualization can be changed. This provides a natural interaction metaphor and frees the main visualization from visual noise. Here you can see how the interaction with the proxy looks like. First, we load some sensor data, and then we can grab it and change the transformation of the displayed data. We can also sort the displayed sensor data based on a measure of anomaly. Here, we select to sort the data, and as you can see, users can easily identify anomalous data by the given highlights in the sorting of the axis. Currently, we're looking into ergonomic analytics directly in the virtual reality, for example, together with assembly simulation. This would allow users to directly evaluate the ergonomic aspects of design while simulating their use in virtual reality. Additionally, we are further developing the collaboration aspects of our systems, especially for assembly and design reviews. We will also be analyzing the movement from psychological experiments that are evaluating the differences of user movement based on different stimuli like presence or pain. And finally, we would like to add methods time measurement considerations to our assembly system to improve decision making. Thank you for your attention, and we look forward to discussing our topics in more detail with anyone who is interested.